ahead and get started today. We're doing FSA Practice Packet 3. Okay, so the first question says, which statements are true? Select all that apply. It says the slope of line AC is equal to the slope of BC. Notice that AC is the exact same line as line BC. So if they are the exact same line, then they definitely will have the same slope. The next one says slope of AC is equal to the slope of BD. Again, AC is the same line as BD. So it is going to have the same slope. The slope of AC is equal to the slope of line T. AC is the same line as line T. So it is going to have the same slope. The next one says the slope of line T is equal to EC over AE. So the slope of line the slope of line T is going to be rise over run. Remember, that is how we find slope. Rise over run. How much is it going up? And then how much is it going over? So this is going up 1, 2, 3. Up 3 over 1, 2, 3, 5, 6. Up 3 over 6, which reduces down to 1/2. So the slope of line T is 1 over 2, or 1/2. Then this said that is equal. This says that is equal to EC, okay, which we know is 6, over AE, which is 3. 6 over 3 reduces to 2 over 1. It does not reduce to 1 over 2. So that is not correct. The next one says the slope of line T is equal to FB over FD. FB is 2 over FD, which is 4. That reduces to 1/2, so that is true. The slope of line T is equal to AE over FD. AE is 3 over FD, which is 4. 3/4 is not equal to 1/2, so that is not true. So you should have the first 3 marked and then the 5th one marked as well. Okay, it says that points A, B, C, and D are collinear, which of the following must be true? Well, if we look back, it says A, B, and C, D have the same slope. Notice that AB, line AB, and line CD do have the same slope. They are on the same line, so that is true. So A is our answer. That is correct. Because they are on the same line. Their slope is 1 over 2. Yay! Okay, the next one is asking for the equation for the line below. This problem and others like it are very important. This is going to come up quite often on FSA. Important problem. So focus on this one. We want to make sure that this is in y equals mx plus b form. This is slope-intercept form. Our m stands for our slope. Our b stands for our y-intercept. Our y-intercept is where our line crosses the y-axis. Our y-intercept is also our initial value, or where we begin. Our slope is rise over run. It can also be called the rate of change. Okay, so we want to put this in y equals mx plus b form. First, we need to know where it crosses the y-axis, which is 0. I'm going to go ahead and put my variables y and x already in my formula of y equals mx plus b. And then all we need is our slope. We are going to do rise over run. I'm going to pick 2 points that are on the line. And then we are going to go and connect them. We are going to go up 3 and over 1. So rise over run, how much we went up was 3 over run, we went over 1. So 3 over 1 is our slope. So you could have also written it like y equals 3x because we don't need that plus 0 on the end, and 3 divided by 1 does give us 3. So either one of these answers would have been correct. We are doing the same thing with this problem. Okay, again, we want to put this in slope-intercept form. Okay, where it crosses our y-axis is at -15. So for B, I'm going to put -15. And then remember, we need to be looking at our graphs carefully. In a lot of problems, you'll see that the graphs count by ones. In this particular case, it does not count by ones, and that's important because we don't want to get our slope incorrect because of this. Okay, so it's counting by fives. So I'm going to pick this dot and the one that's already given to us for our y-intercept, and we're going to find our slope with these two dots. Okay, so we went up 5, 10, 15, and 20. And then over 5, 10, 15. Okay, notice that if we are moving from left to right, that our slope or line is going down. If it is going down, then our slope is going to be negative. So we can go ahead and put a negative in front of our slope. Okay, so remember rise over run. So our number going up is supposed to be going first on top. So that's 20, and then 15 will go on bottom. This can be reduced because you can divide both of these by 5. 20 divided by 5 gives us 4, and 15 divided by 5 gives us 3. So remember it's going to be negative because our line is moving down. So our answer is -4/3 x minus 15. You could have left it y equals -20 over 15x minus 15, and that would have been correct as well. But it's always better to reduce if you can. Make sure if you are reducing that you are reducing correctly. Okay, here I'm going to use the distributive property to distribute the numbers on the outside of the parentheses to the numbers inside the parentheses. 9 times 3 gives me 27, and 9 times -2x gives me -18x. 2 times 10 gives me 20, and 2 times -8 gives me -16x. Remember, we want our variables on one side and our numbers on the other side. Okay, so I can start this by adding 18x to both sides. This cancels, and I'm left with 27 on the left, and 20, and -16 plus 18 gives me +2x. Remember, I cannot add my 18x to my 20 because one has a variable and one does not, which means they are not like terms. Okay, we want to get our 20 on the left side, so we are going to subtract 20 from both sides. And we are left with 2x is equal to 27 minus 20, which is 7. We want to divide both sides by 2 because x is being multiplied times 2, so we have to do the opposite, which is divide both sides by 2. Remember, whatever you do to one side of the equal sign, you must do to the other because it is equal. Okay, so 2 divided by 2 is 1, and 1 times x is just x, and x is equal to 7 over 2. You could also say that x is equal to 3.5 because 7 divided by 2 is 3.5, but you could also leave it in fraction form. X is equal to 7 over 2. Okay, -4 times 2x gives me -8x. -4 times 9 is -36. Don't forget this +3x. -4 times x gives me -4x. Don't forget the 6 up front. And -4 times -3 gives me a +12. Remember, we want our variables on one side and our numbers on the other. Okay, so we want to combine like terms if we can. So over on this side, we can combine our two variables with numbers, coefficients, and our -8x plus 3x gives me -5x, and we still have the -36 on this side. And over here, we want to combine our constants or our numbers without variables. So 6 plus 12 gives me 18 minus the 4x. Again, we want our numbers on one side and our variables on the other. So I'm going to get rid of this 36 by adding it to both sides. Remember, to get rid of something, you have to do the opposite of what it's telling you to do. So we wanted to add 36 to both sides. So now we are left with negative 5x, and 18 plus 36 gives me 54 minus 4x. And we want to add 4x to both sides. This cancels, and we are left with 54 is equal to negative 5x plus 4x, which is negative 1x. And we can divide both sides by negative 1 to get the x by itself. So x is equal to 54 divided by negative 1, which is negative 54. And that is our answer. Okay, here, a couple of things we want to know about this one. I'm going to go ahead and type it up so that we have it to follow. Okay, copy down this at the bottom here because that is going to be helpful to you. Okay, these are just good notes to have for when comparing how many solutions an equation will have. Okay, if we look at the two different sides of this equation, they are completely different. When they are completely different, there is exactly one solution. If just one thing is different from either side, it is no solution. If they are the same, which multiplying by 1/2 and dividing by 2 are the same, they are going to be infinitely many solutions. And the next one, 3y plus 6y gives us 9y, and 9y minus 9y is 0. And so 0 equals 0. They are the same, so infinitely many. And if you see here, the two sides are completely different, so this is going to be exactly one solution. So again, make sure that you write down these notes here at the bottom for this problem, because it is super important to remember that when dealing with these types of problems, and you will have these types of problems come up on FSA. Okay, it says an equation is shown. How many solutions does the equation have? Explain your reasoning. Again, they are completely the same on both sides. So our answer is going to be infinitely, sorry, it's really hard to write with this thing, infinitely many solutions. Okay, and this is because if you put any number in for the variable j, it will be equal, equal on both sides of the equation. Okay, make sure to write all of this down for this problem. Okay, so an equation is shown. 3x plus 10 equals 4x plus 10. How many solutions does this have? Now, it does look like there is just one thing that's different from both of these, which would make this no solutions. However, the one thing that is different is our x's, which means that it is not that they are completely different. It is going to be one solution, but we can prove this by actually completing this problem. Remember, we want our letters or variables on one side and our numbers on the other. 10 plus 10 gives me 0, and 3x minus 4x gives me negative 1x. Okay, and we can divide both sides by negative 1. and x is equal to 0 divided by negative 1, which is 0. So when x is equal to 0, and it can be equal to 0, because as we know on the coordinate plane, there are zeros on the coordinate plane. So our answer for this equation is one solution. Okay, here we are dealing with the same thing again. These two equations are the same, so it's going to be infinitely many. These are completely different, so it's going to be exactly one solution. These only have one thing that's different between them, and so that is no solutions. The next problem, they are the same, so it is going to be infinitely many. And you can make sure that they're the same by dividing both sides here by 8. And so y is going to equal negative 8 divided by 8, which is negative 1x. And negative 1x is the same thing as negative x. So these two are exactly the same, which will be infinitely many. And the next two are completely different. So it is going to be exactly one solution. Okay, so it says the two lines are graphed on the same coordinate plane. The lines intersect at the point 3, 6, which of these systems of linear equations could represent the two lines. Select all that apply. Okay, so what you could do here for this problem is to, I'm going to copy this and move it here. Sorry, un momento, please. Okay, so it wants us to see if our solutions for these two lines are going to be at the point of 3, 6. So line x equals 3 is going to be this line on x. And y equals 6 will be here. So yes, their solution, or where they cross, will be at 3, 6. So that is correct. The next one, it says x equals 6 plus y, which is really saying y equals x minus 6, because we would subtract 6 from both sides in order to get y by itself. So we are going to start graphing the y-intercept at negative 6, and then we are going to go up 1 and over 1, because when x is our slope, it has a coefficient of 1 over 1, so our slope is 1 over 1. Now the next one is 3 plus x, so x plus 3 would be the same thing. So we want to start at positive 3, and again it's up 1 over 1 for our slope. As you can see here, the lines are parallel, they will never touch. Oops. So that first one was correct and the second one was not. Our next one is 3x minus 3. So at negative 3, I'm going to put a dot, and then I'm going to go up 3 and over 1. And I'm going to keep doing that. Our next one is x minus 1, so negative 1, and then it's up 1 over 1 from there. And they do cross, these lines do cross. Let me draw the line so maybe that'll be easier to see. Okay, here was our first line. Sorry, I'm terrible at drawing with this. The pen is very finicky. Okay, you see that they do meet here, even though it's hard to tell from my awful lines. Okay, they do meet at positive 1, positive 1. They do not meet at 3, positive 6. So that is going to be not true. Okay, our next one is 3y. 3 plus y equals x, so y equals x minus 3. So at negative 3, and then we're going to go up 1 over 1 with this as well. And then x plus 6 is our next equation. So we're going to go to positive 6, and we're going to go up 1 over 1. Again, they are not going to touch. So only the first one so far has been has had a solution at 3, positive 3, positive 6. Okay, and our next one, x plus 3 starts at positive 3, and then we go up 1 over 1. Okay, this one does go to 3, 6 on the on that point. So let's see if the bottom equation does 2x. So that does not have a y-intercept, so we are going to start at 0, and then we are going to go up to and over 1. Up to over 1. Up to over 1. So they do meet at this point, which is 3, 6. Okay, so that one is correct as well. So the first one and the last one for these problems. This problem. We are almost done, just a few more problems left. Okay, it says a system of 2 equations is shown. Graph the 2 lines below and identify the solution. Remember, a solution here, a solution of equations, is going to be an ordered pair. With an x value and a y value. Okay, this is our x and this is our y. Okay, so let's go ahead and graph these equations. So I'm going to start with our y-intercept here at -3 and put a dot. And then I'm going to go up 1 and over 1, 2, 3. Up 1 and over 1, 2, 3. Okay, so that is my first line. Our next one starts at +5. And it looks like they're not going to touch, but just wait. Let's do the slope. And we are going down 1 to the right 1. It is a negative slope, so we are going down. So, because we're going down and it's a negative slope, they are going to cross right at +6, -1. Okay, so +6, -1. Oops. Okay, it says a graph of a system of 2 equations is shown, and it shows you that these are at the tens. 9, 8, 7, 6, 5, 4, 3, 2, 1. So these are counting by ones. It says, what is the approximate solution of the system? So our x value, if I draw a line straight down, our x value is right in between the 1 and the 2. So anywhere in between the 1 and the 2 would be a fine answer. So I'm going to just pick it directly in between, which is 1.5. You could have picked any number in between 1 and 2, and I would have taken that as a correct answer. Up here, let's see where it goes to the y-axis. That is in between the 3 and the 4 on the y-axis, so I'm going to pick 3.5, but any number in between 3 and 4, and I would have given you credit for that answer. Okay, a system of 2 equations is shown. What is the solution of the system? Okay, we already know that x is equal to 10. It really just tells us that right there. Okay, so now that we know that x is equal to 10, we can replace the x with 10 and solve for y. So 3 times 10 plus 5y equals 20. 3 times 10 is 30, so 30 plus 5y equals 20. We are going to subtract 30 from both sides because we want our variable by itself. So we need to get rid of everything except for our variable. 2 minus 30 gives us -10. We want to divide both sides by 5 because we want the y by itself, and y is being multiplied by 5 right now, and so we need to get rid of it by doing the opposite, which is dividing by 5. We are left with y is equal to -10 divided by 5, which is -2. So y is equal to -2. That is where these 2 lines will cross. Last one, yay! Okay, it says Cedro bought 5 games and 8 songs for a total cost of $22.87. Benita bought 7 songs and 4 games for a total cost of $18.89. The cost of their purchases can be represented by the following equations. 5G, 5G plus 8S equals 2287, and 7S plus 4G equals 1889, where G is the cost of each game and S is the cost of each song purchased. What was the cost of each game and each song purchased? Okay, so here what we want to do is we want to solve for both of these, just like the system of equations that we've been working on. Okay, so how I can do that is I can cancel out the G's so that I can solve for the S, and then once I have the solution for the S, I can then input it into the problems in order to solve for the G. So we're doing one in order to solve for the other. So what I'm going to do is I'm going to multiply both problems, the entire problem, in order to get rid of it. So I'm going to multiply this whole problem by 4. And the reason I'm doing that is because this second equation has a 4 with the G. And if we're crossing out the G's, I want to multiply the whole top equation. I want to multiply the whole top equation with 4. Now the bottom equation, I want to multiply by 5. It's going to be a negative 5 though, because again, we are trying to get rid of the G's. Okay, so when we use the distributive property, 4 times 5 gives us 20G. Sorry, 4 times 5G gives us 20G. 4 times 8S gives us 32S. And 4 times 2287 gives us $91.48. Negative 5 times 4 gives us negative 20G. And you can see here why I ended up picking the opposite of 5G, which is negative 5, so that we can cancel out the 20G and the negative G. Negative 5 times 7S gives us negative 35S. And negative 5 times 1889 is negative 9445. Okay, so here we are going to add these two equations together. We're getting rid of 20G minus 20G. That cancels. 32S plus a negative 35S gives us a negative 3S. And 91.48 minus 94.45 gives us a negative 2.97. We're going to divide both sides by negative 3. We're left with S is equal to 99 hundredths. Okay, so we know that S is equal to 99 hundredths. So now we can insert S into the problems. So 5G plus 8 times 0.99 equals 22.87. Okay, so 5G, 8 times 0.99, okay, is 7 and 92 hundredths. And 2287 stays over here. We want to get rid of the 792. We're left with 5G on our left, and 2287 minus 792 gives us 1495. I'm going to come over here. So now we have 5G equals 1495, And I'm going to divide both sides by 5 to get G by itself. G is equal to 1495 divided by 5, which gives us 299, or 2 and 99 hundredths. Okay, so S is 0.99 and G is equal to 2 and 99 hundredths. All right, you guys did a wonderful job today. Make sure to copy down all of these in your notes because I am going to be grading this. This will be an easy 100 for you. Just make sure that all of the notes that I have here are in your notes on your practice paper that you worked on. Okay, have a great day. I'll see you guys when I get back.